Hi, let us solve some more questions from the chapter fins. This question says that one end of two long cylindrical rods, two long, that means infinitely long fin cylindrical rods of the same diameter is also same, but different materials. Okay, so K is different. K is different. Is attached to a base surface maintained at 100 degrees Celsius. That means it is the root temperature, T naught. The surfaces of the rods are exposed to ambient air at 20 degrees Celsius, which is same for both the cases. That is, this is T infinity. By traversing the length of each rod with a thermocouple, it was observed that the temperatures of the rods were equal at the positions x is 0.15 meters and xb is equal to 0.045 meters, where x is measured from the base surface. If the thermal conductivity of rod A is known to be 70 watt per meter Kelvin, the value of Kb for rod B will be. Okay. So you have been given that temperature T at the respective distances in both the rods is equal. Okay. So this is a case of infinitely long fin. Okay. Because it's given that one end of two long cylindrical rods. Okay. So let's use the formula for temperature profile. What it says that theta by theta naught, which is equal to T minus T infinity by T naught minus T infinity is equal to e raised to the power minus mx. Okay. So at x is equal to xa, t is, let it be t. Okay. T infinity is same for both the cases. Okay. T naught is also same for both the cases, for both A and B. Okay. And T is also same for both the rods. However, this x is different. Okay. So this, let this be for case 1, let this be xa, and for case 2, t minus t infinity upon t naught minus t infinity. I'm directly taking the ratio. Okay. Ratio. E raised to power minus mxb for case 2, but I've directly taken the ratios. This and this will get cancelled out. Okay. So that implies e raised to the power minus mxa is equal to e raised to the power minus mxb. Okay. Take natural log on both the sides. Okay. So mxa is equal to mxb. We are left with this only. Now what is mhp by kac for A? xa is equal to root hp by kac for B, xb. Okay. Now it is given that the heat transfer coefficient is same for both the cases, so this gets cancelled out. Okay. Diameter is same, that means PAC will get cancelled out because it is a cylindrical rod, and for cylindrical rod perimeter is pi d and the cross section area is pi by 4d square. Diameter is same, so this and this gets cancelled out. So this is xa upon root ka and this is xb upon root kb. We know xa, xb, we know ka. We can find out kb. Okay. So I'm directly squaring it. So this is xa square by Ka is equal to xb square by kb. Okay. So that implies kb is equal to xb square upon xa square into Ka. So xb square, xb is 0.045 square upon this is xa square. Xa is 0.15, 0.15 square into Ka. Ka is 70. So when you solve it, Kb will be equal to 6.3 watt per meter Kelvin. Okay, that is option C. Okay, so this will be option C. See, in every question we are just using the temperature profiles and whether the rate of heat transfer. So this was also a simple question. So option C is your answer. Okay. Let's move on to the next question. It's a nice question. If you want to attempt it yourself, you can do it. Okay. Yeah. So two ends of copper rod, K is given, diameter is given, and length is given, are connected to two walls, each maintained at 300 degrees Celsius. Draw the schematic diagram. This is a wall, suppose. This is also a wall. So it says that both the ends of the copper rod are connected to two walls, and both the walls are maintained at what? 300 degrees Celsius. 300 degrees Celsius. Okay. Air is blown across the rod with a heat transfer coefficient 20 H, 20 watt per meter square Kelvin. Air temperature is 20 degrees Celsius. That is T infinity is 20 degrees Celsius. What you have to find? Oh, you have to find the midpoint temperature of the rod. Okay. This is a different type of question, and I will tell you how you have to analyze this question. See what happens when a rod is connected to two walls at the same temperature. You can actually treat this rod as two fins. Okay, what will happen? The heat will be conducted in the fin from this side, and the heat will be conducted in the fin from this side also. Okay, so the temperature here and here are same at a distance x, and at this distance x will be same. So if you construct the profile, temperature profile, it will be somewhat like this. That at midpoint the temperature will be lowest. Okay, at midpoint the temperature will be lowest at a distance x from the from the left hand side. If the temperature is T, then at the same distance x from the right hand side, the temperature will also be T. Okay, so this is how you analyze this problem. You consider it as a case of two fins connected together. Okay, so the temperature profile will be like this. The temperature will be lowest at the midpoint. Why? Because I've told you that the heat will be conducted from this side also and from this side also. It will be conducted from both the sides. Okay, so at a distance x from this side, if the temperature is T, then from this side at the same distance x, the temperature will again be T. Okay, this is the temperature profile. So we know that at midpoint the temperature of the rod will be lowest. Okay, this is confirmed. Now you have to find the temperature of the midpoint of the rod. So for that, what we have the temperature profiles. Okay, so we can use the formula for temperature profile, but for that, before using that, we actually have to find the case that whether it is whether the temperature profile which we'll be using will be a first case, that is infinitely long fin, or whether it will be for the second case, that is insulated fin. Okay, and for that, if nothing is mentioned in the question, you always have to check that ml is greater than or not 2.56. In some books it is taken as 2.86, but generally we use ml is greater than equal to 2.56. Okay, so if ml is greater than equal to 2.56, the fin, the case will be of infinitely long fin. Okay, so let's check this condition. M is equal to root hp by KAC. Okay. H is given, P is given because diameter is given, so P will be pi d. Okay. K is given and AC is again pi by 4 d square. You can put all the values and you can get the value of M, which will be, I'm directly writing the answer of M, which will be which is, I guess, yeah, 3.746. 3.746. This is M per meter. Okay. And L, in this case, what will be L? L will be half the length of this rod, because this one fin is actually being treated as two fins. Okay. The reason I've told you. So L here will be L by 2 actually. Okay. So L is what? L is 300 mm long. That is one rod. So length of each fin will be 150 mm long. That is, L will be 0.15 meter. Okay. So when you multiply it, ml, that implies ml will be equal to, I'm writing the answer. Oh, this is not given. Okay, let me calculate it. It will be 3.746 into 0.15. So it is 0.5619. 0.5619. That means it is less than 2.56. That means it is a case of insulated tip fin. Okay. Insulated tip fin. If it was greater than equal to 2.56, then it would have been a case of infinitely long fin. But since it is less than 2.56, this ml value is less than 2.56, it is a case of insulated tip fin. Okay. Now what? Now you know the temperature profile for the insulated tip fin, that is theta by theta naught is equal to T minus T infinity upon T naught minus T infinity is equal to cos hyperbolic M. L will be L by 2 here. Okay, be careful. Everywhere now L will be L by 2 actually, because we are treating this case as of two fins. So L by 2 minus X upon cos hyperbolic M L by 2 again. Okay. So now where do we have to find the temperature? This T. This is we have to find. But where? We have to find that at midpoint. Midpoint is what? Midpoint is L by 2 again. X is L by 2 only. Okay. So this becomes 0. Cos hyperbolic 0 is 1. Okay. And this ML by 2, you know, this is actually L by 2. Okay. Will not confuse it. This is ML by 2 is 0.5619. This you know. This value you can find out. Okay. T infinity is what? T infinity is ambient temperature is 20 degrees Celsius. Okay. So this you know, that is 20 degrees Celsius. And what is the root temperature? The root temperature is 300 degrees Celsius, because the walls are maintained at 300 degrees Celsius. So this you also know. This is 300 degrees Celsius. Okay. So everything you have everything with you. You can find T. Okay. So the answer of T will be equal to 263.7 degrees Celsius. 263.7 degrees Celsius. This is just the calculation part. You can do it again. Cos hyperbolic 1 will be, sorry, cos hyperbolic 0 will be 1. This is L by 2 minus L by 2. This will be 0. Cos hyperbolic 0 is 1. Okay. So this you have found out, ML by 2 cos hyperbolic. ML by 2 you can find the value. Put all the values, you can get the answer. Okay. Let's move on to the next question. Okay. So a 50 cross 50 mm iron bar, that is square cross section, 0.4 meter long rectangular fin, is connected to the walls of two heated reservoirs, each at 120 degrees Celsius. Same question. Do it yourself. Okay, before seeing the solution, try it yourself. This is an important question actually, and has been asked in many examinations. Okay, all you have to do is just treat one rod as two fins. Okay, and wherever the term L comes, length term comes, put it as L by 2. Why? I've actually given you the reason in the previous question. So let's start this. Just solve this. So again, the walls are maintained at 120 degrees Celsius. Okay, and 50 cross 50 iron bar square cross section. The length is 0.4 meter long. This total length is 0.4 meter long. Okay, the temperature profile will be like this only. At midpoint, the temperature will be lowest. The ambient air temperature is 35 degrees Celsius, that is T infinity is given, and the convective heat transfer coefficient is also given. The thermal conductivity is given, the rate of heat loss from the bar, and the temperature of the bar midway between the reservoirs are respectively. Okay. So again, this question has been asked that you have to find the temperature of the bar midway between the reservoirs. This you can find out by using the temperature profile. I'll do it. But the rate of heat loss from the bar, consider this as two fins. Okay, calculate the heat loss from one fin and multiply it by 2. But in case of wherever the term length comes, put L is equal to L by 2. Simple. Okay. So first of all, we'll have to check whether it is case 1 or case 2. That is the case of infinitely long fin or the case of insulated tip. Okay. Whenever we'll be analyzing it, we have to actually see whether we have to analyze this problem by taking case 1 or by taking case 2. And for that, we have to check ML, whether ML is greater than or equal to 2.56 or not. Okay. So let's find out M first of all. M is what? Root HP by KAC. Okay. And H is 17.4. 17.4. Okay. Perimeter. This is our fin. Perimeter will be 4 into this side. So 4 into 0.05 meter. Okay. Upon K. K is 52 watt per meter Kelvin. Cross section area, side square, that is 0.05 square. Okay. So this M will be equal to, this M is equal to 5.174. 5.174 meter inverse. Okay. Now here L will be what? L will be L by 2. So L is equal to L by 2 here. That is 0.2 meter. Multiply 5.174 into 0.2. This will be equal to, this comes out to be equal to 1.0348. 1.034. This is actually ML by 2. Okay, do not get confused. I'm taking a case of single fin. Okay. So this is 1.0348. This is less than 2.56. So that means this is again not a case of infinitely long fin. This is a case of insulated tip fin. Insulated tip fin. Insulated tip fin. And for insulated tip fin, what is the rate of heat transfer through fin? Q through fin. What is it? It is H P K AC T naught minus T infinity tan hyperbolic ML. This is the answer. Okay. H is what? H is H. That is the data given. I will tell you the data. H is 17.4. P is P is 4 into 0.05. K is what? K is 52. Let me write it only. H is 17.4. P is 4 into 0.05. 50 mm is given. K is what? K is 52 watt per meter Kelvin. AC is again 0.05 square. Okay, T naught minus T infinity. This will be, the walls are maintained at 120 degrees Celsius and the ambient temperature is 35 degrees Celsius. So 120 minus 35 and tan hyperbolic ml. This is actually L by 2. Okay, so ml by 2 is 1.0348. So 1.0348. Okay, you multiply this and you'll get Q through one fin. Okay, this will be 44.37 watt, and Q total will be twice of this value, which will be equal to 88.74. Why it will be twice? I've told you, because the rate of heat conducted through this fin will be equal to rate of heat conducted through this fin. I'm actually separating these two fins. Okay, taking these as two fins. So some part of heat will be going here, some part of heat will be going from this side, and they both will be equal. Okay, so total will be twice of this value. This is the Q total, 88.74 watt. Okay, this is the first part, that is the rate of heat loss from the bar. Okay, and the temperature of the bar midway between the reservoirs are respectively. This you can solve on your own. Okay, let me solve it. So this will be, I'm going to solve it. So what was this case? This was a case of insulated tip fin. Okay, and for insulated tip fin, T minus T infinity upon T naught minus T infinity is equal to cos hyperbolic M L or L by 2? L by 2 minus X upon cos hyperbolic ML. However, in this case it will be L by 2. Okay, T naught, T infinity, you have these things with you. Okay, X will be what? X will be L by 2, because you have to find it at the midpoint only, and that is equal to L by 2. That is actually at the tip of one fin. If you take the cases of both the fins, if you take the case of two fins, this X is equal to L by 2 is actually at the tip of one fin. Okay, so this will be 0, cos hyperbolic 0 is 1. So this will be 1 upon cos hyperbolic. What was this value? ML by 2 was 1.0348. 1.0348. And this is T infinity is, I guess, 35. What this is? This is 35. T naught is 120 minus 35. So T will be equal to, whatever be the answer, will be, I guess, 88.8 degrees Celsius. 88.8 degrees Celsius. This will be the answer. This is an important question. Many a times it has been seen in the exam, and it has been seen in various exams. Let's move on to the next question. Next question is a cylindrical pin fin. Cylindrical pin fin of diameter 0.6 centimeter and length 3 centimeter with a negligible heat loss from the tip. Great. That means it is a case of insulated tip fin. Insulated tip fin. Okay. So it is an efficiency of 0.7 and you have to find the effectiveness of this fin. Okay, write the formulas. Questions on this chapter are directly based on the formulas. Okay. So for insulated tip fin, what is the efficiency of the fin equal to? It is equal to tan hyperbolic ml upon ml. Okay. And What is the effectiveness of this fin equal to insulated tip fin? This is equal to root pk by HAC tan hyperbolic ml. Okay. Now actually I have to find tan hyperbolic ml. This is the problem. Okay, for us. This we have to find. But the value of efficiency is given to us, that is 0.7 is equal to tan hyperbolic ml upon ml. So I can replace this tan hyperbolic ml with 0.7 ml. Okay, because I can actually put the formula of m, which will be equal to root hp by kac. Okay, so 0.7 ml is equal to tan hyperbolic ml. Okay, this I am putting here. Okay, so this becomes, effectiveness becomes root pk by HAC. Tan HML is 0.7 ml. Great. I put the value of m, put the formula of m. This will be, effectiveness will be equal to root pk by HAC. 0.7 m is equal to root hp by kac, and I guess it was L here. Yeah, yes. So this root h and this root h gets cancelled out. This root k and this root k gets cancelled out. This is root p upon AC into 0.7 into L. Great. Now I can solve this question because diameter and length are given to us. So P is pi d and area of cross section is pi by 4d square. This is 0.7 and L is what? L is 3 centimeter. Let it be L only. This gets cancelled out, this gets cancelled out, and this will be 4 0.7 L upon D. Put L in centimeters or millimeters or meter, because eventually the units will get cancelled out. Okay, so L is 6 centimeter, sorry, L is 3 centimeter and diameter is 0.6 centimeter. Solve it. Effectiveness will be equal to 40. So it's again a nice question. The use of both efficiency and effectiveness. You'll be expecting very basic questions in the examination from the chapter friends. Again, let's do this question. It states that a steel rod of 12 mm in diameter and 60 mm long with an insulated end. Again, the information is given. So this is insulated end, is to be used as a spine. It is exposed to surroundings with temperature of 60 degrees Celsius and a heat transfer coefficient of 55 watt per meter square degree Celsius. For this fin, the efficiency is found that 4 to be, this should be 2b, 62.18%. Then the effectiveness of the fin is, I guess this is the same type of question. Okay, so do it yourself before seeing the solution. Okay. So if you have done this, if you have attempted this yourself, for insulated tip fin, efficiency is tan hyperbolic ml upon ml. Okay, and effectiveness for insulated tip fin is root pk by HAC. Okay, tan hyperbolic ml. So again, this problem arises that you have to find the value of tan hyperbolic ml, because you don't know the value of k, so you cannot find the value of m. But I have the relationship of efficiency with me, so 0.6218 is equal to tan hyperbolic ml upon ml. So that implies tan hyperbolic ml is equal to 0.6218 ml. This I can directly put. Put this here, this here. Okay, so this will be again the same type of question, that is root pk by HAC into 0.6218 ml. M is root HP by KAC L. Okay. So this root H and root H gets cancelled out. Root K gets cancelled out. It will be P upon AC into 0.6218 into L. That is, effectiveness will be equal to P by AC 0.6218 into L, and P by AC will be 4 by T, I guess. Yeah, 4 by T 0.6218 L. Okay, you put the answer, put the value. Diameter is 12 mm and length is 60 mm. You put these values and the effectiveness value will be 12.43. Okay. This will be the answer. So I've tried covering all types of questions that can be asked. I mean, obviously, we always expect, we cannot expect similar type of questions in the exam, but I've tried covering the questions that actually deal in all the concepts that are required for fins. Basically, you will be getting questions from temperature profile and heat transfer rate through the fin, and some questions will be there on efficiency or effectiveness, and that too I have explained in the previous video. So this is all for fins, and prepare this topic thoroughly. It is an easy one and it is scoring. Thanks.